Find the limit of each of the following. The first one, we have the limit as x approaches infinity of 1 over x. Okay, so in this case, the degree of the denominator is higher than the degree of the numerator. So on that basis, we can say that, it's going to be equal to 0. Another way of thinking about that, though, is just really like you've got 1 over some extremely large number, right? So then we're going to be getting closer and closer to 0, right? Okay, the next one. So now we've got the same degree in the numerator and in the denominator, right? Degree of 1. Now, what we have been doing is taking the limit of each individual term and dividing by the highest degree, right? So that's what we've done in the past, and that works. That's great. But the other way to think about this, right, is really like if you sub in infinity in for x here, then you can imagine this -5 is just infinitesimally small, right? Like it doesn't hold a candle to the power of infinity going into this spot, right? So for all extents and purposes, this -5 is completely meaningless. And same with this 2 on the bottom. So this really becomes the same thing as just the limit as x approaches infinity of 3x over 6x in the end. Now, our x's in this case, you can think of as canceling, so we really just have 3 over 6 or 1 over 2. So these ones are really easy that you can just kind of look at your leading coefficients out front and determine what the limit is. Okay, now on this one, this can be a little bit trickier. So now if I look at the degree of my numerator, well, it's 3, and the degree of the denominator is 2. So in this case, it does not exist, right? So that's true. That is the answer. But if I was actually sketching this thing, it'd be handy to know, like as my graph starts going towards negative infinity, because that's what this is saying, right? What does my y value do, right? Does it like veer off this way, or does it veer off this way, like towards positive infinity or negative infinity? So the way we can figure that one out is we can think about what would happen if you put negative infinity in for x. And I know negative infinity isn't actually a number, right? So but we can, kind of get away with it. We're gonna do the same little trick here where the constant terms, like this 5, again, is almost like completely meaningless. This might as well be 0 for all we care, right? When we're talking about infinity, especially infinity cubed going in here. So think of this as like 0 minus, and then this is like infinity going in here. So far you've got -4, just dropping the 5 really. And then just picture for a second you've got negative infinity going in for x. Okay, so now negative infinity cubed. So since it's cubed, it's still going to be negative infinity in the numerator there. So here I'm just writing the numerator out right now. So when we're done now, we're still going to have -4 times infinity. Negative infinity cubed is still negative infinity. And then you can see now I've got -4 times negative infinity, so that's going to come out positive, right? But now, just for a second, let's focus down on the bottom here, because now if I threw negative infinity in for x, okay, so let's do that. So if I have 10 times negative infinity squared plus 7 times negative infinity minus 12. Okay, so again, the minus 12 didn't even matter, right, when we're talking about infinities. And then, but if we look over here, right, I've got negative infinity squared. That's coming out positive. Okay, so that's like, so this is really like positive infinity, this whole first part. Okay, and it's being squared, right? So this is actually growing faster than this one. So this positive infinity is growing faster than this negative infinity. So I only was really concerned about the biggest power. Okay, so I got kind of messy there, but in the end, if we go back, you just take like the highest exponent, right, on the one in the denominator here. So I only really cared about this because this was doing all the work, right? This squared is growing faster than this one. So that's what I'm going to use. So then again, now, so if I move on over to the next one, 10, again, the 10 didn't even really matter, did it? But we'll just leave it. So 10, and then times, and this becomes positive infinity because we were squared. So now we've got -4 times negative infinity, so that's coming out positive, and the bottom's already positive. So this is going to be positive infinity. So like I said, the reason why that's helpful is because now I know when I go to the left, this graph is going to veer off towards positive infinity.